Here's their fun thing. I just love these cells. Lymphocytes. They will migrate to lymphatic tissue and proliferate. All right, let's think about that. They're going to be produced from that pluripotent stem cell in the bone marrow. They will get into the blood circulation, and they will have to go to lymphatic tissue and proliferate, meaning increase in number. What did I just tell you? What is going to be my lymphatic tissue? My lymph nodes. What was the one organ that I mentioned from our endocrine system? Huh? What?
Thymus.
My thymus. T cells, B cells. Heard of those? Why have you heard of T cells? HIV. Because what happens? Of the HIV virus makes those T cell numbers go down. B cells. Now, think about this for a second. What was the one gland from that endocrine system that I said involuted, got smaller as we got older to a point where it actually disappears? My thymus. Oh. So, that tells me a couple of things. I got to make T cells while I can, right? Because the more T cells I can get, they're making memory cells. So, the more stuff I can get exposed to and build up an immunity to it, the better off I'm going to be when I get older, when this thing's gone.
So you get back.
Yeah. Yeah. Mm-hmm. That's what the vaccines are supposed to do. Don't get me wrong on vaccines. Okay. Now. I am. The more that you can get, okay, that's building up. So, because as you get older, your ability to fight stuff off is going to be harder to do, okay? B cells, they can be produced, okay? And they can migrate to the lymph nodes, and they can be there ready to work. But now, can you see how important these lymphocytes are? The other thing that the lymphocytes, okay, they are responsible for producing antibodies. When antibodies have to be produced, the immune system has now gotten very specific. It is going after one thing and one thing only with those antibodies. So the lymphocytes, they definitely are high in number. They're making up about 20 to 25% of that white blood cell count, and they'll increase in number when we have an infection, when there's some type of immune response that's going to be needed. And as they do this, okay, with the lymphocytes, they're going to actually be able, now remember, I'm saying lymphocytes as a whole. I'm not pointing out T cells or B cells, okay? The tissues that they'll be able to migrate to for being the lymph tissues, they'll be able to go into the lymph nodes. They'll be able to go to the thymus. They'll be able to go to the spleen. They'll be able to go to the tonsils, okay? They're going to be able to go into these lymph tissues. When they're needed, they're going to be called up, okay? Now, when these cells work, one of the things that they can do, they can present antigens and help activate other immune cells. Now, that becomes extremely important when we move into the chapter on the immune system. That means these cells, because the body has not been able to fight off that antigen, that thing that's trying to invade the body, because it hasn't been able to do that, it will take a piece of the cell that's trying to invade it, take a piece of it, and present it to these immune cells, okay, and say, hey, we need you to come help us. And it will cause these other immune cells to go to work. It's a really cool process. But at that point, we've gotten very specific. Now, for the T cells, like we said, they're going to go to the thymus. They're going to get exposed to that chemical of the thymus gland, the thymosin, okay? And they will mature in that thymus gland. And once they are mature, they'll leave the thymus gland, and then they can go and sit in this lymph tissue. The B cells are going to produce antibodies when they get stimulated. All right? So the B cells, they get produced, but when they get stimulated by something such as a bacteria or a toxin, what will happen is these antibodies, they can attach, like if that B cell produced the antibodies, that antibody can actually attach to that bacteria or that virus, okay? And what it'll do is it'll activate mechanisms to destroy it. For example, what was our first antibiotic ever? Penicillin. Do you remember when it got developed? No. It was actually earlier, okay? And it was tested on the military in World War II before it came out into public. For military, everything's tested on them first, you know. I mean, hey. But anyway, once they found out the ability of penicillin, okay, it was a very simple action that penicillin did. The bacteria, penicillin could attack it, punch little holes in the cell wall of the bacteria. Water from the body could enter the bacteria and make it burst. That's all it did. That's pretty cool for an antibiotic, similar to what the B cells can do. However, today, do you hear about penicillin being used very much? Why? Well, there are people who are allergic to it, but you know, there's stuff they do for that. Get over that. But, well, now there's a difference between virus and bacteria. They're two different things. Antibiotics can only be used against a bacteria. So, if you're sick now with a bacteria, they can give you a medication that's maybe 4 pills. But you go and you get that medication filled, and it costs you $1,000 for those 4 pills. Do you know why? We have created such super bacteria, okay, that they have had to engineer medications to attack the DNA of the bacteria, to kill it. And that's why you might have to pay $1,000 for 4 pills. Viruses. It used to be we had nothing. You had to just simply give the body the materials that it needed, like fluids and stuff like that, and hope that the body fought it off. We do have some antivirals now, okay, that are used, and I think there's some pretty good success with that, but a virus is a virus. You can't really do a whole lot with that because viruses are constantly changing. So we're really dependent on the body being able to attack that. So this whole response, these cells right here, when we get into the immune chapter, these are coming back to us because of what they do. And it is so cool. Now, the monocytes. The monocytes, what will happen in the case of a viral infection and then inflammation? And inflammation is something we have in our bodies all the time, okay? The better you can keep your inflammation down in the body, the better you'll feel, all right? Now, the cool thing about monocytes, they'll remain in the circulation about 3 days, okay? They'll increase in number. Once again, that pluripotent stem cell, they'll get into the circulation, they will leave the bloodstream at the area of those capillaries, move into the tissues where they are needed, and they will become macrophages, large eaters. Okay? So they'll become macrophages. They will simply phagocytize, eat the pathogens, and then they'll also eat debris. Now, the cool thing that will happen with the monocytes, they become very important for being an antigen presenting cell, an APC. Because what they get to do, they can take that antigen and they can attack it. And as they attack it, if they're attacking it and they're like, oh, hey, whoa, you know, I'm done. I can't handle all of you, okay? What it'll do is that cell that it ate, that we're being invaded by, and it can't control it, it'll push a piece of it up to its plasma membrane, and then it'll go to and present what it can't handle. Guess to which cells? My lymphocytes. And that will be stimulating a response from those cells to help fight this pathogen. So some of the things that they'll do, they'll release chemical messengers, and they're going to phagocytize and present those little foreign pieces. This is what they look like under the scope. Now, something that I've kept mentioning, creation of these cells. What was the term used for production of the red blood cells? And I'm going to go to table 3. Table 4. Table 2. The hematopoiesis. Now, we've got leukopoiesis, our production of the white blood cell. We are going to have a hematopoietic stem cell, all right? That can differentiate. Now, watch the lineage. Do you guys know what lineage means? Your family, the steps of your family. Mom, grandparents, great-grandparents, great-great-grandparents. Okay? Watch the lineage for the white blood cells. It's going to differentiate into a myeloblast. If we have the term blast, what does that mean? Gives rise to. Okay? Monoblast, lymphoblast. These two are pretty easy, right? Our A granulocytes. Myelo forms neutros, eos, basos. Our granulocytes. Red bone marrow. Because these are coming from my pluripotent stem cell. What else did my pluripotent stem cell give rise to? Table 4. Huh? All right, but what part? If this was the white blood cell, what did it give rise to? The red blood cell. Table 2, can you think of anything else it gave rise to? Platelets. Pluripotent stem cell. PPSC. Don't forget that. Okay? Now, white blood cells, they're not going to simply stay in the bloodstream. Okay? Granulocytes leave from that red blood, from that circulation, live about 5 days. Monocytes travel in it for about 20 hours, but then they'll leave, migrate into the tissue, and become those macrophages. And they live for a long time. Lymphocytes, that's our long term, because they're going to leave as they are immature, go to that lymph tissue, mature, and then sit and wait. They're going to wait for, most likely, the monocyte to come in and present something to them. And when that happens, they're going to increase in number and go attack that something. Does that make sense? Now, my lineage. My lineage. One cell, that pluripotent stem cell, is going to give rise to all of these formed elements in the blood. Does that blow anybody else's mind? Why? And if you think about it, this organism as a whole, one cell, gives rise to all of these elements. It just amazes me. So we end up with granulose, agranulose, red blood cells, platelets. We got it all. Can things go wrong with this?